In this lecture we will look at the integrals in which we find powers of the sine or of the cosine. For example, look at this integral. The integral of sine to the power 4 of x cosine x dx is equal, of course, to 1 over 5 times the sine to the power 5 of x up to a constant c. Or maybe this was too quick. Let me explain it. Well, we use a substitution. We use u is equal to the sine of x, and then find that d of u is cosine x dx, and our integral from sinus to the power 4 of x times cosine x dx can of course be rewritten as the integral of u to the power 4 du, and then this is equal to 1 over 5 u to the power 5 plus a constant. And now, since u was equal to the sine of x, we find 1 over 5 sine to the power 5x dx plus c. Here another example of this type, but now there is an integral of sine to the power 4 of x times cosine to the power 3 of x dx. Well, this cosine to the power 3 of x we can rewrite as cosine squared times cosine x. And cosine squared is of course 1 minus sine squared. So we find this is sine to the power 4 of x minus sine to the power 6 of x times cosine x dx. And now we use again the same substitution. U is sine of x, and we get u to the power 4 minus u to the power 6 du, and our primitive and antiderivative is 1 over 5 sine to the power 5 of x minus 1 over 7 sine to the power 7x plus a constant. And this technique can of course be applied to any powers of the sine times cosine to any power n of x, where m or n, or maybe both, are odd. But what about sine to the power m times cosine to the power m, where m and n are both even? Well, to handle those kind of integrals, we use that the cosine of 2x can be written as 2 times cosine squared of x minus 1, but also as 1 minus 2 sine squared of x. So look at the easiest example. If we want to compute the integral over sine squared of x dx, then we use the above formula to rewrite this as an integral over a function where only cosine or sine of 2x is used. So we use that sine squared of x is a half minus a half cosine 2x, and we have the integral over that dx. And now we know an antiderivative of this. It's a half x minus 1 over 4 sine of 2x plus a constant. If we look at the other case where the cosine now has a square and the sine is not present, then we use the same trick. But now the cosine square of x is equal to a half plus a half cosine of 2x dx. And again, we easily find an antiderivative being a half x plus 1/4 times sine of 2x plus a constant. But what about higher powers? Suppose sine to the power 4x dx has to be integrated. Then that is of course sine square of x squared dx. And now we can replace sine square of x by a half minus a half cosine 2x and find the following integral. But if we expand now this square, we find that this is the integral over 1 over 4 minus a half times cosine 2 of x plus 1/4 cosine squared of 2x dx. Now, again, we see that we have a cosine square. So we use that cosine square of 2x is a half plus a half times cosine of 4x. And then we find that there is an antiderivative of 1 over 4, which is 1 over 4x. an antiderivative of a half cosine 2x, which is minus 1/4 sine of 2x, and the cosine square we rewrite as 1/4 times the integral of a half plus a half cosine of 4x dx. But now again, this integral can be easily computed as we can find some antiderivative. And we find as a final answer 1/4 times x minus 1/4 times sine of 2x plus 1/4 times, between brackets, an antiderivative of a half is a half x, and an antiderivative of a half times cosine 4 of x is 1/8 times the sine of 4 of x. And then we have to add the integration constant c. We have handled now integrals involving sines and cosines to any power. But how about the tangent? Well, the integral of the tangent of x dx is of course the integral of sine of x divided by cosine x dx. Using u is equal to cosine of x, we find that du is minus sine of x dx. So our integral is equal to the integral of minus 1 over u du. And we find that the integral is equal to minus ln of the absolute value of u plus a constant. So it's minus ln of the absolute value of the cosine of x plus a constant. One more tangent. Well, now let's take the power of a tangent. So we have the integral of tangent square of x dx. That's of course the integral of sine squared divided by cosine squared dx. And now replacing sine squared by 1 minus cosine squared, we find the integral of 1 minus cosine squared dx divided by cosine squared of x. This is equal to the integral of 1 divided by cosine squared of x minus 1 dx, and 1 over cosine squared has an antiderivative, tangent of x. 1 has an antiderivative of x, so we find tangent x minus x plus the integration constant c. A different way to remember this is, of course, that the derivative of the tangent is equal to tangent square x plus 1. So an antiderivative of the tangent of x minus x is equal to the tangent square of x. So that was another way to see this. But we have also used the previous techniques to find the antiderivative.